STEAM and STEM is not just about creating programmers. It's about building thinkers who has the ability of adaptation, problem solving, and also creating value in any future. But in order to accommodate for the different grades, we basically clustered them into 3 different sections. So we have grade 1 to grade 3, which is the simpler one. Not only do they learn some basic building and building their foundation in robotics, using concepts and connecting them together, they actually get to understand interest in science. For example, when we learn the fulcrum and we use real-life examples, an individual trying to push the entire planet. Now, that will be something that connects over back to the robotics side. The difficult ones will come when it comes to grade 4 to 6, where they will start learning how to use some basic coding, which is a blockly version, where they will connect the blocks itself together, as well as engineering basics, where they will build their own robots, statistical training, and having creative thinking at the same time. The difficult part would be at grade 7 to 9, where students get a more detailed structured learning, such as they would get to touch C++, Python, and they would get to use more complex building, such as not just individual projects, but making it into a more complexity project. For example, a 3D printer, building something more sophisticated, in order to meet and comprehend that itself.
Our STEAM curriculum is matched with the National Youth Robotics level tests. As we progress through the curriculum, we prepare the students to sign up and to take these tests. Yes, we give them a special training just ahead of it to go through all the contents. This will earn them certificates that are nationally recognized. The STEAM course is one of the many fact teacher taught subjects in this school. The language that, of course, we teach in is English, which pushes the students, that drives them to learn a lot, to expand their English vocabulary. When we're talking about technical terms that have to do with mechanics, robotics, and programming, so we take this into consideration, the challenging aspect of it. The teaching materials that we use, they break these terms, and explain it very detailed to them.
We normally use learn by doing and speak by doing approach. So it's not just like telling them what to do, but rather than showing them and allowing them to feel for it. For example, integrate. We could put one side, and put them together, integrate. Not just that, but allowing them to also go into it and do that stuff before whatever new learning procedures or processes. This way, they would have a physical touch on it. They'll be able to interpret the English languages much more clearer and faster. Basically, we follow a 40% theory and a 60% building base, where they would have a physical feeling for the model itself. Why does this work? It's because 1, they get higher engagement, 2, they get direct feedback from it, and 3, they always have a loop back to whatever they are doing. For example, students would get to build the tank model itself, and then think about how to modify the speed, the accuracy, as well as how to modify the angle itself in order for the robot itself to advance or use, or in practical usage. We also allow them to trial and error, so sort of like a test, a fail, and improve. So failing is okay, it's fine.
STEAM, part of its learning goals is very much about problem solving and logical and systematic thinking. Through the practice of programming, students can really widen their perspective about how these technologies not just making life easier and more convenient, but safer and make our world more efficient.
Basically, we introduce real-world applications, industry examples, future careers as well. Students become more orientated, and they are more motivated and more goal-orientated, and that's the key part. I hope students, not just to be users of technology, but be creators of the future.
就是一开始不懂 STEAM 课程的时候，我就感觉眼花缭乱。我以前是不会很自觉的那种搭建机器人的，现在搭的越来越好了。以前是搭小车，现在都可以搭那种避障的小车。避障小车就是它发现前面有个障碍物，它可以自动避让。我以前的梦想本来是当个警察嘛，但是我现在发现科技越来越发展更快了，然后我觉得以后当一个编程机器人的专家也可以。我想做那种给人类服务的机器人。
We participate in robotics as well as AI competitions. All these are all based on fundamentals of outside, for example, WRC, VEX robotics, and so on and so forth. But most importantly, in LWS, we provide essential guidance, as well as we also give them teacher support. We also give them materials support. We will guide them towards the competition itself. So, for example, they would have robotics failures before competition. They will also have some disagreements between each other. So how we handle it is we allow them to have debugging mindsets. We also allow them to have structured work. But the biggest gain out of the whole thing will be students will be able to build resilience and also problem solving on their own. We also focus on long-term impact for students, such as we allow them to be able to find out what their goals are. They will be able to find out challenges. They can adjust their mindsets, and most importantly, when they face the outside world, they are able to beforehand have the equipment skill down here itself.
All the experience that they're having here is already connecting them to the international world. We are already giving them the tools and make that bridge easier to cross. So remember what you've learned and keep that out-of-the-box thinking. Keep that wide perspective and open curiosity, and you can adapt to any new environment.
I wish you guys all the best and hope to see you soon in LWS.